All right, folks, thanks for coming. Our next topic will be Venn diagram in this video, okay? That's all we're going to cover. What is a Venn diagram? Well, it was discovered by this guy. See this guy here called John Venn. John Venn. His last name is Venn. That's why it's called Venn diagram. I guess it's his diagram. So I want to do things a little bit different this morning. So the Venn diagram, you're looking at the map of the United States there. According to John Venn, first of all, the Venn diagram is used. It's a form of diagrammatic representation of sets. That's what the meaning of Venn diagram. It's used to represent sets diagrammatically, or you can say in figures, right? So it's a way to represent sets in images, in figures. That way you can visualize it. Okay? According to John Venn, right? He said that the universal set, first you gotta start with an universal set. The universal set is represented by a big rectangle, right? And then the other sets, the subsets of the universal sets, are represented by circles. That's how he designed it. But we don't necessarily have to have rectangles or circles, right? You can use big square as the universal set, and then use little squares as the subsets of the universal set. It's okay, it will work too. This is just a way to visualize what the sets are doing when you do operations on the set, right? So look at the map of the United States there. See, you can look at the whole map of the U.S. as if you want, call it a big rectangle, right? See, these are the rest of the stuff there. You can also go all the way up, see? But check this, why I like this map, why I want to use this map you're looking at here. If you put your mouse here, see, this is Washington. Their capital is Olympia. This is Oregon. Their capital is Salem. This is California. Their capital there is Sacramento. Alright, see? And then if you go to Northeast, you have Maine. By the way, I remember I talked about these three states here. They are called the west coast of the U.S., those three states. Now, if you go to Northeast here, you have Maine. Maine has capital Augusta, right? What is that? New Hampshire, their capital is Concord, right? New York, their capital is Albany. Pennsylvania, their capital is Harrisburg. You see why I like this map? So you can look at that West Virginia, Richmond, Maryland, Annapolis, North Carolina, Raleigh. See, you can do that. This is Colorado, Denver is the capital right there. New Mexico, Santa Fe, Texas, Austin, Oklahoma City, Kansas, Topeka, Nebraska, Lincoln, South Dakota, what's that, Pierre? I never heard about that one. Wyoming, Cheyenne, But anyway, Arkansas, Little Rock. So, if you consider all these states, right, consider them as subsets. Each set is a subset of the big USA. So Oregon is a subset of the entire United States. Washington is a subset of the United States. But if you put those three states together, they can form a set. Those three sets form a set, but their set is still the subset of the United States. You see that? So that's how you understand that. That's the language, mathematicians use. I just want you to understand that. Use what you know to visualize it, right? Texas is a subset of the United States. All those states in the northeast. I think there are 11 states. Remember we talked about that? If you weren't here when we talked about that, go look at my videos. You will see that I discussed them. All those 11 states form their own. They form states because they group them under northeast. So northeast it consists of 11 states. Those 11 states called the northeast. The northeast is a subset of the United States. That's all. So if you just mess around with it like that, you will see. Okay, this is Alaska here. You know what? When I was looking at this, I noticed something. Check this out. Maybe I should know. This is Alaska here. What is this? This is Hawaii. Look at that. Hawaii is over there in the ocean, but it says, man, one day ocean maybe swallow that thing there. And look at part of Alaska. See, some people probably will say Junior. Look at that. See, that's part of Alaska, Bering Sea, Mexico. And then Mexico is here. That's the one that really got me looking. See where Mexico is? Mexico is right there, all the way. See how tall it is? All the way over here. Basically, in the language of set, this is Alaska, it's Mexico, right? You can say that Alaska is a disjoint set from the U.S. See, the U.S. and Alaska, they disjoint, even though they belong to the same country, right? But if you look at I don't want to say it like that. Look at the state of Alaska, it's disjoint from other states. If we consider them in the language of set, the state of Alaska and the rest of the U.S. form a disjoint. They form a disjoint set. And you know what is a disjoint set? Two sets are disjoint when they don't have anything in common. I don't know if the language is appropriate here because you cannot say Alaska and the main United States don't have anything in common. Yes, they do. They're the same country. And they have the same culture, the same practices, the same thinking, everything the same president, right? So, but anyway, that's the language of set. They're distinct, right? They're different. And look at Mexico compared to Texas. You see how they're distinct, even though they have a common boundary. For example, Colorado is distinct from New Mexico, right? But they're in the same country. They are each set, but they all belong. Those two sets belong to the big set, the universal set called the U.S., right? But notice that they have a common boundary. They're distinct, which means they have a common boundary. That's how you read that. They have a common boundary with Alaska and with Mexico, but they're distinct. You can't remove the boundary. If you remove the boundary, then they're not distinct anymore. Just over here, if you remove the boundary between New Mexico and Colorado, then the two states are not distinct anymore. They're the same states, but you can't do that by law. You see, these are conventions, the conventions created by human beings, right? So I was looking at this, I thought this is very interesting. So I said, let me bring it to your attention. So anyway, the big USA is an universal set, right? Where other states belong to that universal state. That's how I read that. All right, folks, let me give you one more example with something that should be familiar to you. You see, look at the big red rectangle, right? That constitutes an universal set according to John Venn. And then the dark small rectangle inside of it constitutes a subset of the big set, right? The subset of the universal set. Notice what I did. I looked at the 12 months of the year, and then I picked out 4 months that ends in ER, or you can say they end in BER, right? Those 4 months I formed a set with them. and the set, that particular set is the subset of the 12 months, right? That particular set is the subset of the universal set. So you have two sets there: universal set that contains all the months of the year. And then from there, I formed a set that contains 4 months out of those 12 months, okay? So you can play around with it. You can form different things based on whatever you think, whatever you're trying to decide. Okay, let's do some programs. Let the universal set be the set of the states in the west coast of the United States, and then the C A is defined like that, B, C, and then J. What we want to do is we want to represent the situation using the Venn diagram. Okay, see, I have drawn the universal set right there, and then what you say A. You draw A like that, and notice that A and B has nothing in common, so you draw B like that, and notice that C has nothing in common with A or B, so you draw C like that. Notice that J has something in common with A, right? So you draw J like that. This is J. So now you put the elements. See, W is there. No, I'm sorry. Actually, no. W, they share W. See, that's why you gotta pay attention. I guess I'm not paying attention. W is right here. All right, and then for J, 1 is right here. For B, Oregon is anywhere there. For C, California is there, right? So this is the representation. You just have to pay attention, to see which set intersects, which set does not intersect, right? Okay, let's do another example. Look at that one there. Set AB has a universal set, right? I've drawn the universal set, and then universal set is actually defined there: 6, 7, 8, 10, the elements of the universal set, right? And then see how A is defined, how B is defined, and then we want to represent that using the Venn diagram. So what you say, you draw. Well, first of all, notice that A and B has nothing in common. So what you do, you draw A, you draw B. This is A and this is B. A has 7 and B has 10 right there. By the way, what you're supposed to do, you see, A and B did not exhaust they didn't use up all the elements of the universal set. So you're supposed to put the elements left. Supposed to put them here. What is left is 6 and the 8, right? Supposed to put them there like that. That way, when somebody looks at it, they can see all the elements involved, right? All right. Okay. So let's go to the next example. We'll have he says A is a subset of B. That's the universal set there. Then you say, since A is inside of B, you draw B like this. This is B, right? And then A is inside. You put A inside. This is A. That's how that goes, right? Now, I think, given that situation, if we will not say, let A be just set, let B be that set, right? Let me see, I have to get it in here, that way you can see it. Let A be that set, let B be that set, right? Then, what do? We'll say, we'll do another representation right here. This is universal set, right? Sorry, I think I'm calling this up. This is universal set, and then notice that A and B has 20 in common. So that's possible, because then what happens is we'll still draw B, right? And then A is still inside, and then but A has 20, and then B has the rest of the stuff 18 and 22, right? Notice that 20 is still inside B, right? Okay, that's how you represent that. Now let's consider another example. I'm gonna expand this a little bit. Okay, let's consider another example like that. Oh man, just give me a minute. This stuff is giving me a problem. Let's consider another example like that. You have K defined like that, T defined like that. Okay, we want to represent it using the Venn diagram. You draw the universal set. Okay, it says the universal set is a subset of natural numbers, right? You know what is natural number? Counting numbers 1, 2, 3, 4 to infinity, right? And then see, look at K and the T. Do they have anything in common? No. So you draw them like that. This is K and this is T. K has 40 and 41, and T has 61 and 81. Notice that K and T has nothing in common, which means they disjoint. They're called, remember disjoint, we discussed that, disjoint sets. They are disjoint, right? They don't have anything in common. Alright? So let's do another example. Let's go down, do another example. Oh, okay, so we're giving a bunch of sets. We just want to represent them using the Venn diagram. Basically, you are told that A and B has universal set, right? You don't have to stipulate what they are. So, okay, because we're not dealing with numbers right here. See, we're not dealing with numbers. We just want to see how all those things are represented, right? Okay. So, A union B will have a universal set somewhere there. Universal set. What is A union B? Remember our definition. A union B is the set of all elements that A and B contains, right? You remember that definition? So basically you draw it like that. They will have something in common. A here, B here. Now, the best thing to do here when you don't have elements, you need to shade them. Okay, so the A union B is everything right there, except anything in the universal set. But let me see, so right there, well, they contain element of universal set. So the elements are the elements of universal. But this is how you shade them. I think I showed you something like this when I first started, right? Okay, so let's do A intersection B. A intersection B, you proceed the same way. Just remember the definition, right? What is the definition? A intersection B is a set that consists of elements common to A and B. Remember? Okay. So they have something in common. You draw it like that, and it's right here. Elements common to both of them is right there. Okay. Now, what of the complement set? The complement of A. Basically things that are universal set that are not in A, right there. I think that's how we define it, right? Okay. What of A minus B? The difference between A and B is called difference of sets. How do you draw that? You start with universal set, and then the difference of set is it consists of a set with the elements of A that are not in B, right? Okay, so you draw A like that, draw B like that, A, B. So the elements that are in A but not in B. Basically, subtracted element of B from A. So whatever is here, you shade it like that. Whatever is here, but see? A and B don't share it, so you can't put it in this in that intersection box. So it's like that. It's shaded like that. All right. So as long as you remember the definitions, right? So long as you remember the definition, things are easier like that. Now let's do this problem here. This problem says, it says that the universal set is the set of all the 50 states of the United States, right? And then A is given there, B is given there. Notice that A is the states in the West Coast, and B contains some states in the West Coast, and then P, I think P, I use P for Pennsylvania. Pennsylvania is in the northeast, right? Now, how do you represent this situation using the Venn diagram? That's the thing. That's the thing we're supposed to do. So we'll say the universal set like that. And then notice that A and B has something in common. They have W and O in common, right? So you draw it like this. Okay, they have something in common. This is A and this is B. All right. What do they have in common? They have W and O, right? And then this one has C by itself. This one has B by itself. You see how you proceed? Because you see, A still contains all its elements. B still contains all its elements, right? Okay. So let's do another one that has to do with United States. Let the universal set be all the states of the United States, the 50 states. Again, I give almost similar example. Set A has all the states in the West Coast. Set B has Pennsylvania and Texas, right? Notice that they don't have anything in common. So how do you represent that? You go like that, universal set. You said that they don't have anything in common, so they don't have to intersect, right? You see where the language is important. Those two sets got nothing in common, so why would they intersect? They got nothing in common, right? So you say A, B, and then this is A here, the elements of A, put it anywhere you want, P and T. You see, that's what is going on there. So notice another terminology we used before. We said that those two sets are disjoint, right? They got nothing in common. They do not intersect, right? They are disjoint. Alright, this is our last example. I chose that carefully. Notice that universal set is a subset of the whole numbers. What are the whole numbers? A set of whole numbers is given by W equals to big W equals to it contains 0, 1, 2 to infinity, right? Now, the best way to approach this, right, is to try to find out what those two sets actually contain. Try to figure it out before you proceed. Okay, so you've seen this before, right? Set A contains all the elements including 1 and 7. Set B doesn't contain 1 and 7, but every other thing in there it contains, right? So let's write it out. A is equals to 1, 2, 3, 4, 5, 6, and 7, right? And then B is equals to it doesn't contain 1, so it's 2, 3, 4, 5, 6. It doesn't contain 7, so we're done with that one. See, that's how you write that. Now I think there's more questions here. He asks, see right here is down there, but I think I can do it up here. Yeah, I can do it up here. So he asks you to find A intersection B. What is A intersection B? And he asks you to find also A union B. All right, A union B. That's what they want you to find. A union B. Okay, so let's do intersection first. So, what is intersection? An intersection is what those two sets are having in common, right? Always remember that. So, from A and B above, we can say the intersection. See, they have 2, 3, 4, 5, 6 in common, right? So you write that 2, 3, 4, 5, 6. These are the only things they have in common. What of A union B, right? A union B is everything. A union B is a set that contains all the elements of both sets, right? So we'll list everything. It's one, but no repetition. 2, 3, 4, 5, 6, right? And 7. No repetition, see? That's it right there. You can't write 1 and then write 1 again, 2, then write 2 again. No. The elements of each set has to be distinct. No repetition. I think that's all I have there. Please subscribe to my channel, like and share this video, leave comments and questions under the video. I will answer them as soon as I can. Thanks for coming. I'll see you. Oh, by the way, I have only 2 topics left in set theory. The first topic I have left is called relations, and the second topic is called functions. I may be able to do both topics in one video. I'll see about that. All right. Thanks for coming.